All right, folks, this video is on how to solve Objective 5.1's problems all the way from level 1 to level 3. For level 1, prove the triangles shown are congruent. In level 1, I'm not going to be expecting you to do more than just cite what theorem you're using. So in this case, we look at this side, and I notice that those are congruent to each other. Congruent to this and this. So those two are congruent and those two are congruent. I don't have an extra piece here, but I do see some vertical angles. So this angle and this angle are congruent to one another. And because those are vertical angles. So you can cite that they are congruent by the side angle side theorem. And that's really all you got to do. You say they're congruent by side angle side, and that's it. I wish I could get this to write a little thinner, but okay. All right, next one. These already have three pieces marked. They're not connected in any way, but it's side, side, and side. And then they're matching on the other one side, side, and side. So we can just say congruent by SSS. And that's the side, side, side theorem. This last one, you might think it's not enough information until you realize that they share a side here in the middle. So this green side is matching between both triangles, therefore it's congruent to itself, and so we can apply the angle side angle theorem. So ASA, congruent by ASA. If you're not sure how to tell the difference between the different ones, this is a good time to go and watch the other video that I posted on how to tell them apart, which is also on Google Classroom. All right, level 2. Now we have to actually write some proofs here. We are given that RS bisects PQ at T, so I'm going to start off by writing if RS bisects PQ, that means that at T, that means that PQ, which is this line segment, is getting bisected. Bisected means cut into two congruent parts. So that means that QT and PT are congruent. QT and PT. So I'll put markings on those, and I'll write PT segment is congruent to segment QT because, and I can write BC for because, T bisects PQ. This is another way of saying that RS bisects PQ at T, but I think it's a little bit simpler. T bisects PQ. T is cutting PQ in half. Secondly, so I'll just put that as step 1. Step 2 is to turn this into something. Try and practice, see if you can figure out what I'm going to say. PQ bisects RS at T. Bisects RS. So RS is getting cut in half. Here's RS. Cut it into two equal parts. So those two match each other. In other words, RT is congruent to TS or ST because T bisects. And what's the thing that's getting cut in half? Well, the T is cutting R to S in half. So it bisects RS, and it says it right there, bisects RS. And we also have vertical angles, just like we did in the other one. So in red here, those two angles are congruent to each other. So step 3, angle RTS is congruent to angle PTS because they're vertical. And now we just make a conclusion. The conclusion after 3 steps is usually when you're going to do a conclusion for this kind of proof. You're going to do 3 steps, one for the sides, one for each of the sides, and one for each of the angles. So 3 steps because it's angle, even if it's angle, side, angle, you'll do 2 angles and 1 side, etc. Now, sometimes people get messed up because they think, oh, this is side, and this is angle, so is it side, side, angle? But we could have written these in any order we wanted. We didn't have to do them in that order. What you do is you look at the picture, and it looks like a side, angle, and then side, with the angle right in between. Again, if you don't know how to tell the difference between side, and angle, side, for instance, then go back and watch my other video, which is also posted on Google Classroom. Okay, so the conclusion is triangle RTQ. Actually, I guess we'll use the phrasing that's right up here. That's safe. PTS is congruent to triangle QTR. And that's because both of those triangles share that common side, angle, side pattern. So we'll say by SAS. Got to cite that part. Very important. By SAS. Because we're using a side, angle, side pattern. That's what we're doing here. With this one, we are given that DA is congruent to CB. So the very first thing we should do is we should mark DA and CB with the same marking. And I will then mark the second given, that DA is perpendicular to AB. So I'll mark these. I'll try to color code them nicely. Here's green and green, actually. So in green, DA is perpendicular to AB. That means this is perpendicular to this. In other words, that angle is 90 degrees. And then in red, CB is perpendicular to AB. Here's CB, and here's AB. And we're saying that that's 90 degrees. 90 degrees. And they want you to prove that DAB is congruent to CBA. This is a little weird because they overlap, but it's not anything that's crazy here. DAB, I'll highlight that in yellow, or outline it in yellow. Triangle DAB is congruent to triangle, and in black, I'll do triangle CBA. There's triangle CBA. Its 3 vertices are C, B, and A. All right, so the black and the yellow triangles are congruent. We just got to prove it. I will draw the black triangle out here and what it has as its markings with each color. And then I'll draw the yellow one. And this allows me to sort of separate them so that it's easier to tell what kind of test we're going to be using. And in blue. So we have 2 90-degree angles here. Since those are 90 degrees, they have to be matching. Even though they're different colors as I put them, these 2 90-degree angles are congruent to each other. So right now we've got a side and an angle, and a side and an angle. So in order to get this to work, we might want to do side, angle, side. So for side, angle, side to work, we would need side, angle. We would need this side to be congruent to this side. But in fact, it is, because look at these bottom parts. They are congruent because at the bottom, they're both AB. So I can even put an extra marking on here in green for this side is congruent to itself. And that's AB. All right, and now it's a little clearer that I'm going to be using a side, angle, side pattern. Side, angle, side. In that order, with the angle in between the 2 sides. So let's write our proof. We'll start off by saying DA is congruent to CB because it's given. We'll then say that angle DAB is congruent to angle CBA. Since they're both 90 degrees. So this is 1 and 2 and 3 would be AB is congruent to itself. That's talking about this side. And I'll just write of course, but I guess it would be by the reflexive property. So we'll say reflexive there, but you can just say of course because it's equal to itself, right? AB and AB are the same thing. So 4 is the conclusion. We're going to use the side, angle, side theorem. Again, remember what you're doing is you are just saying, is this side, are these two triangles congruent? Yes, they are. How do you know? Because I can prove the side, the angle, and the side are congruent to the side, the angle, and the side, respectively. And that's right here. We have our side, our angle, and our side. So step 4, by SAS, and then just our conclusion. Triangle DAB is congruent to triangle CABA. Level 3. This is where you start doing the exact same thing as before, but you start applying a little bit more of your own extra knowledge to it. With this one, everything that was needed to do SAS was really just given to you. You were given that these two angles are 90 degrees. You were given this. AB is congruent to itself because, of course, everything is congruent to itself. But in the next one, you're going to have to think a little bit more and add a little bit of your extra own pizzazz to it. So they give you that SR and ST are straight lines, so we can be confirmed that this and this are not tilted in any way. They're just extra saying that for us. SX is congruent to SY, so there. XR is congruent to YT. So I'll mark YT and XR with that same marking. And in fact, I'm just going to highlight them in their respective colors as well, so that you can see sort of what they're made up of. That immediately leads me to believe that this side is congruent to this side. And that would probably be helpful because we're trying to prove that RSY is congruent to TSX. RSY. Where is RSY? RSY. If you're not sure where the triangle is, just start at the first vertex, second vertex, third vertex. That is the triangle in green. And then in red, I will put the other triangle, TSX. That's S, T, and X. So those are the triangles that we are concerned with. Let's clean up this picture a little bit. So in red, I have triangle TSX. And in, forget what color I used, we'll say yellow, I have triangle RSY. It was green before, but now it's yellow, sorry. So if we want to show that those triangles are congruent, we need some congruent pieces. I'm going to start off with the fact that they both share angle S. So angle S is congruent to angle S by the reflexive property. Second step I might do would be that, I'm looking at what things are congruent. Well, they both share this side. So we'll say SY is congruent to SX. Why? Because that one's given. And now, so those so far are just things we kind of already know. Of course, things are congruent to themselves, right? Everything is congruent to itself. It might not be given, so it's not drawing your attention to it in the problem, but you can see physically that the yellow triangle and the red triangle both have this green angle, angle S, inside of them. So angle S is congruent to angle S. Side SY is congruent to side SX. That's given. And finally, we kind of have to pull some stuff together. Remember I said earlier that this is congruent to this. ST and SR are congruent. So let's write that down. ST is congruent to SR. And why are they congruent? Well, they're made up of the same two pieces, right? This one is made up of a side of this length, however long it is, and this length. So you just add the two together. SY plus YT is going to equal ST. And then the same thing on the other side. These two add up together. But they're the same two pieces. So the two lines, ST and SR, are made up of the exact same two pieces as each other. So they have to be congruent. So segment ST and segment SR are congruent because they are made of the same two lengths or sides. You're just combining two of them together, and this is already given to be congruent to this. All right, so that's steps 1, 2, and 3. We've got an angle, we've got a side, and we've got a side. Maybe it's the ASS test. Let's check. We know the ASS test doesn't work. But let's see. I like to focus on just one triangle. So in the red triangle, we've got a side, an angle, and then another side. So this is actually side, angle, side. And you can see the same matching pattern here. Side for the yellow one. Side, angle, side. Side, angle, and side. It's hard to see since they overlap, so if you want, draw them separately from each other. And then it's side, angle, side. And for the black one, side, angle, side. And they match in that SAS pattern. So therefore, our conclusion, so we'll call it step 1, 2, 3, and our conclusion, step 4. I'm just numbering them to make it clear what step is which. You don't have to number them if you don't want. By side, angle, side, triangle RSY is congruent to triangle TSX. And we're done. Don't forget to check what triangles you're trying to prove are congruent to each other, because that's really what the trick is to this one. You don't realize what you're trying to prove is congruent at first, because you've got this kind of weird thing where they overlap with each other, but as long as you're able to, in your mind, separate the yellow and the red triangles, and even if you don't have to actually physically draw it like this, as long as you can separate them, it's a lot easier to see. This is the figure that will actually be on the test. So here we go. We are given that ray XM bisects angle WXV. So ray XM bisects WXV. That means splits into two congruent parts. Bisects means splits into two congruent parts, which means that these two parts of the angle are congruent to each other. They also say that WM is bisecting this angle, angle XWZ, which means these two are congruent to each other. They also tell us that WY is congruent to XY. But that makes this triangle isosceles. If the triangle is isosceles, then we can know that its angles are congruent as well. So in yellow here, that angle is congruent to that angle. The two base angles are congruent because the two sides that are opposite them, here and here, are congruent to each other. So if these two yellow ones are congruent and they're both being cut in half, that really means that these two are congruent to these two. So every angle that we've seen so far is nice and congruent. So let's erase some of this stuff. We don't need this anymore because now these markings can match with these markings. Let's write down what we've figured out there so far, which is that by the isosceles triangle theorem, angle WXV is congruent to, that's this one, this yellow one, because X is the middle of that one, and it goes between W and V. WXV is congruent to angle XWZ. XWZ. That's this yellow angle. Remember, being able to name your three-letter angles is super important here. So that's because of the isosceles triangle theorem. That's what ITT stands for, the isosceles triangle theorem. Since those two are congruent, we can say thus, the bisected angles, or the bisections, are also congruent. Now, you could go into so much detail here. You could be like, well, that means that angle XWM is congruent to angle MWZ, is congruent to angle MXV, is congruent to WXM. You could say all that. Don't. That just makes it more confusing. Just talk about the ones that it gets cut in half, the bisections as we call it. The bisections are also congruent. And you can see that in the diagram. They mark it, and you call attention to it by saying the bisections are congruent. All right, now we have just a little bit left to finish up. We actually want to do prove that angle WZM, this angle is congruent to this angle, XVW. Oh yeah, XVW, which is that angle. If we want to show that those are congruent, what we really want to do is show that these triangles, this one and this one, are congruent. If we can show those triangles are congruent, then the angles inside them are going to be congruent. So let's do this one by one. We look at the pieces. I don't really need those two yellow parts anymore, so I'll erase that. Don't really need this. I need an extra piece on these two red triangles. Red triangles. I'll need an extra piece on here and on here. Because right now, I've got a congruent angle here. I've got a congruent side here. So I'll need another angle or side. And, look at this. This is congruent to this. Those two red angles are congruent because they're vertical. So my next step will be angle WMZ is congruent to angle XMV because they're what kind of angles? Vertical angles. Because they're vertical. Now you just look in the two triangles and see, do they have a matching pattern? And it would appear, yes, they do. They have a matching pattern of a side, an angle, and an angle. Or a side that's not between the two angles. That is angle, angle, side. So, by angle, angle, side, AAS, that means triangle WMZ is congruent to triangle XMV. Make sure you put these in the same order. So it's like W matches with X, M matches with itself, and Z matches with V. make sure that they match in that way. It can be in a different order, but they have to match on either side. And if the triangles are congruent, if this blue triangle is congruent to this blue triangle, then that means that the actual angles inside of them are congruent too. So angle WZM, which is this one, is congruent to this one angle, and they call it X. They call it XVW. So going over what this was, you're using that isosceles triangle theorem at the beginning. You may have seen a version of this where I use the isosceles triangle theorem again, the converse. You don't have to do that. As you saw here, I didn't use that this time. I just used the angle side test instead. So there's always creativity and lots of different things that can go into it. There's not one and only one way to do this, ever. However, what you do have to do is you have to make a few logical connections. You can't just be like, I can see angle side right away. You have to decide what you're going to use. So in my case, what I did was I recognized that it was going to be that I could prove I recognized that since I knew this and this were congruent, and I could see that this and this were congruent, and it's already marked that MZ and MV are congruent, now we can apply the angle side theorem. The angle side theorem to show that they are congruent to each other. All right, that's all for this one.